How's it going, everyone? Today we will be working on Project Euler problem number 3. So the prompt goes, the prime factors of 13,195 are 5, 7, 13, and 29. What is the largest prime factor of the number 600,851,400, 600,851,475,143. So I listed the answer that I found online for this problem just to make sure that we're doing it right, so I won't have to look it up later. So yeah, let's get into it. Before we start writing any code, it's always good to list out a game plan. I've been thinking about this one for a while, so first off, it'll be easiest just to compile a list of all the factors for this number. So our first step is just going to be getting the factors in a list, and we'll be using remainder division, or the mod, because that'll let you know if a number equally gets divided into something. And our step 2 is going to be checking if the number is prime or not. And then finally, since we're looking for the largest prime factor, it's just going to be finding largest prime. Okay, so getting into it, step 1 is going to be get the factors into a list. So go ahead and define a function for this. So we'll just call it get factors, and we'll take a number in n. So starting out, we're going to need to create an empty list to hold our factors, so we'll go ahead and do that. And then we'll just start a loop iterating through all of these numbers. It's probably going to take a long time, so we're probably going to switch up this this method, but we'll run it first as is and see if it'll work before we do anything else. So for number in range, and we'll go from 1 to n plus 1. We need to go to plus 1 so it includes it. And then this is where we'll use our remainder division. So if n mod number equals 0, this means that it divides evenly, so it's a factor. Then we are going to add this to our list. So factors.append num. And also, since we are taking factors have two sets, like something easy. We have like 1, 2, 2, 4. So we're going to need both of the factors included. So we're also going to need to include factors. This is factors as well. Factors.append, and I'm just going to use integer division just so make sure I don't get any sort of float values for this. So we'll do n divided by that number as well. So we'll include that. And then that's it for this function. So at the end we can just return our list of factors. Okay, so this is now done. So getting into step 2, we need to check if the number is prime or not. So the easiest way to do this, like I said before, is you take 2 factors for every number. So we're all aware that if a number like such as 7 is prime, the only thing that should be returned is 1 and 7. So all I'm going to do for this function is see if the list size is only 2. Because if it's more than 2, then it has more factors and it's not prime. So the only thing we need to do for this is to return if the length of what we're passing in through get factors is equal to 2. So that's it for that. And then step 2 is now done. So our final step is to just find the largest prime number. So we can start this out make a variable for it, so largest prime equals 0, because we're going to need to compare each value of it. So we also need to create our list of factors from our getFactors function. So I'll create that right now. List of factors equals, it's going to be our getFactors with this large number passed into it. Alright, now we have to find out, we're just going to pass through in a loop and compare our largest prime to the primes coming out of it. So for I in list of factors, we'll do if is prime sorry about that, if is prime, and let me think about this real quick, and if our we called it I, so if our number is larger than, I'm going to change this number real quick, sorry, so if for factor, that'll make it more readable. So when we're looping through our list of factors, we're first checking if this factor is prime or not. Second, we're checking if this factor is larger than our list of factors. If that is the case, then, sorry, I messed up again. Then we're going to check if it's larger than our largest prime. If that is the case, then we're going to reassign our new largest prime to that factor. And that'll be it for that. And then finally we can just print out our largest prime. So like I said before, we're going from 1 to 600 billion, 851 million. So this is probably going to take a long time. If it doesn't work or it just takes a long time, I have a method using some math that'll speed this up a little bit, but I'm just interested see how this will work out. So I'm gonna run it real quick and we'll see if it takes a while. Yeah, so it's looking like it's gonna take a while, so we'll just come up with another method. So, if you guys are interested, I'll time how long this takes and let you guys know how long it takes to iterate through all this on my system. But for the time being, we are going to now import the math library and do something else. So, I'm not an expert on this, but I've seen it online before. If you take this square root of a number, it's more efficient to check the factors, because if a number has a factor larger than its square root, its factor is going to be smaller than its square root as well. Don't question me on this, it's just the way it works out. I'll leave a link down below if I remember, and you'll be able to read up on it yourself if you want. So the only thing now we have to change is, instead of going from range 1 to our number, we're going to go from range 1 to the square root of the number instead, and plus 1 as well to include it. And that should be, actually as well, we're going to have to create an integer out of that. Almost forgot. Range functions, you need to have an integer, so we just have to reassure that that number square roots to this number doesn't look like it's going to come out evenly. So it'll round up too if it needs to, so we'll be fine with that. So now we can go ahead and try to run this program again. And yeah, look how much faster that happened. So there's the answer. This is the code. If you guys have any questions, feel free to leave a comment and I'll help you out. And I'll try to remember to leave that article down in the description. Thanks for watching.